السلام ورحمة.
وعليكم السلام ورحمة الله وبركاته.
Okay.
السلام دكتور مرحبا.
Lecture 3 of Physics 2101.
Doctor,
Yes.
please, I want to tell you something.
Mm-hmm.
Did you see my email yesterday? I wrote in the email that I downloaded the wrong file in the model, and I wasn't able to re-download the correct file for the file answer. So I sent it in your email, the answer.
I have received about 63 emails since the lab ended yesterday until today, and I have not gone through all of them. I will go through them one by one, and I will get back to you on that, okay?
Okay, thanks.
All right, so welcome back to Phys 2101, lecture number 3. Before we start the lecture, I have received a few questions by email, which I received from more than one person. So I'll try to answer them first. First thing first is about memorizing. What do we memorize? There are there are names of scientists. There are names of there are dates, there are definitions of units of length, there are definitions of the SI units, order of magnitude, etc. What do we memorize? What is included in the course? What is not included in the course? So let's break it down to one by one. If a section is included in the course, then whatever is in that section is also included in the course. Okay, so if order of magnitude, for example, is part of section x.x, then that is, and we have covered that section in one way or another, or if it's in the course plan, then that is also covered in the lecture. Now, the other question is, what book do we use? So we use our recommended textbook, or our prescribed textbook for this course is University Physics Volume 1 by OpenStax organization, of which a copy is available in Moodle and online in various formats. That does not mean you cannot use other books. So some of you have copies of the previous book we used to use, Halliday-Resnick. That is also an excellent book. Some of you have copies of other books. Some of you just simply like to read and see different things. For those, I really recommend Feynman's Lectures on Physics. You can use whatever resource you want. You can find videos on YouTube. You can find different textbooks. Introductory physics in most textbooks are pretty much the same, except that the order of material is different. Okay, so if you try to compare our book with Halliday-Resnick, the previous book, you will see the same material, but slightly different order. Okay, actually the slides I'm going to be using today are in large the same slides I was using with Halliday-Resnick. Memorization, there is no such thing as memorization in physics. If you try to memorize the rules, if you try to memorize if you try to memorize the definitions, okay, that's good, but it will not do you any good, because at the end of the day, what you actually need is to understand. Okay, you need to understand the material, and I'm actually going. The first thing we're doing today is section 1.7. Then we're going to chapter 2. In which I'm going to be speaking specifically about how to solve problems in physics in general. Okay, so no, you do not have to memorize names of scientists or names of or dates or things like these. No, you will not get questions like these. This is not the whole point of physics. The whole point of physics is to understand how nature works and work on that basis. Solution manuals to the textbook are available on the OpenStax website for free for students. I have also uploaded copies to Moodle So you can find the solution manual to the questions at the back of to the questions at the back of each chapter. Okay. One of the reasons we chose the OpenStax book is because it is a really, really good book, and it is really useful for students with a lot of resources. Okay, I'm actually going to do something. Let me show you something. I'll share my screen. Okay, so I'll go to openstax.org. Now I am logged in an instructor capacity, but you don't need to be logged in. Okay, if I go to subjects, science, and I scroll down to University Physics Volume 1, this is the entire book. Okay, table of contents, view online, download the app. There's an application for this book that you can download on your phone. You have a PDF copy, you have iBooks, Kindle. You can order a print copy if you want to, but I already informed you that printing might be a cheaper option. Okay, now instructor resources, this is for me. But if I go to student resources, we have student getting started guide. We have a student solution guide. It's available for free to download. Okay, so this is what I did. I clicked on this and I uploaded whatever they gave me onto Moodle. You have expert TA study, you have a time management guide, and you have a reading and note-taking guide. These are really useful things. They're not just here for the show of it. Okay. Yes.
The answer of the solution only odd number questions, not all questions.
Is it only odd number questions? I haven't actually checked.
Like 21, 23, 25.
Doctor?
Yes.
It's locked.
You need to sign up as a student, but the signing up is free. If you just need to sign in with your SQU account. So you sign up with your SQU account because it ends at edu.om. So there's edu in it. They will send you an email for confirmation, and then you can download everything for free. So the lock is just because they need to make sure that you're a student. So you have an email that ends with edu. That's it. Let me see. Solution manuals. I will give you a random one of them.
دكتور وش اسم الموقع؟
OpenStax موجود حتى في المودل. شوفوا الكتاب وين موجود في المودل، موجود هناك لينك. حطيت لكم اياه هنا بعد openstax.org. Okay. Yes, the solutions are for odd number problems. Even number problems, try to do them on your own. If you have issues, we have the tutorials. You can ask in them. If you still have problems after the tutorial, you can email me. We can set up office hours. Okay. All right. Last thing, working hours. As everyone else in SQU, my working hours are 8:30 to 4 p.m. I try to reply to emails as they come to me, but sometimes I get too many of them, so there are delays. Okay, for example, yesterday I got 63 emails from yesterday till today. There's no way I'm going through 63 emails in one day. Okay, so there will be some delays. Emails received after 3:30 or 4 o'clock will most probably be responded to the next working day. So if it's 4:30 on a Thursday, then I will most probably send it, reply to it on Sunday morning. Okay. This thing is not working properly. Just going to ignore this. Okay. So let's continue with the lecture. So we continue now with section 1.7. I will switch my camera to, yes, you might see you might see a very crazy image. Give me a second. Okay, you should be able to see both my face and my screen. Is that correct?
Yes.
Okay,
Yes.
that's perfect. Not FPS, do not apply. Okay. Hopefully. Okay. So, section 1.7, there is a question that students often ask is, this problem is really difficult, or this problem is complicated, or I don't understand this problem. How do we solve it? Okay, this includes labs, tutorials, problems in physics, or problems in life in general. And the general rule is, there's a very easy strategy that we can use to make any difficult problem slightly easier. So, section 1.7.
Doctor,
Yes?
we didn't take 1.6.
We took parts of 1.6. We discussed accuracy and precision. And the significant figure part is actually covered in the lab, in the first lab.
Okay.
Okay. Okay, so how do we solve problems, generally speaking? Well, first thing first is, whenever we get a question, we need to read it very carefully and examine the situation to determine which physical principles are involved. There is a tendency of students to look at a question, see a few key buzzwords, like, for example, mass, speed, velocity, length, and think of the first equation that comes into their head that has these quantities in them, and then simply try to immediately plug the numbers in and get a solution. And this gives a problem.
Doctor,
Going on,
it is
yeah?
opposite.
الكلام
Your
مقلوب؟
screen. Yeah.
Okay. الحين أحسن؟
Yes.
اوكي، اشتغل عدل الحين؟
ايوه طيب.
الجودة يا دكتور.
شوي الدقة تعبانة مو واضح واضح.
ما واضح سكرين؟
أبدا متشوش كامل.
Okay, this is fun. Let me try something. Wonders of online teaching. No, don't stop recording. Send resolution. واضح الحين ولا بعده؟
It is fine.
واضح يا دكتور. ما يعني نص.
اوكي، المرة الماضية الليكتشر الماضي كان واضح؟
أيوة كان واضح.
واضح.
Okay, then option B. I think my camera just died on you. Play. Okay, let's try again. How's it now?
واضح
أحسن؟
واضح دكتور الحين مرة برابر بعد.
Okay.
واضح
واضح.
So it was an issue in the software. I'm using a different software now, so hopefully. Okay, so how do you solve the problems? First, we need to determine physical principles. What does this mean? It means we need to actually slow down, read the question, and understand what is it asking us and what are the physical principles involved. Okay, many times there are multiple equations or multiple things that have the exact same variables in them. Okay, and you will see that in chapter 3 when we start doing motion in a straight line. We have 4 or 5 equations that do the exact same thing. Okay, so we need to figure out what is it exactly that we're trying to do. 2, write down 1, what do I know? 2, what do I think I know? 3, write down what do I want to know? And 4, do the, okay, this is 2 then, math. Now this might sound very, very simple, but you would be amazed how many people don't actually follow through. What happened? Oh, I'm using the same as yesterday. 5, check units. 6, is it crazy? What do I mean by this? Remember the example I told you about Jebel Shams, when it is larger than the distance between here and the moon, and when it was smaller than a tiny stone? So these students failed to follow this logical progression. They figured out that at some point, somehow they figured out they needed to find the height of Jebel Shams. Then they did some sort of math, but they forgot to follow with 5 and 6. They forgot to check their units, because if they checked their units and saw micrometers and megameters, they would immediately know something's wrong. And they failed at number 6 because they did not check, is it crazy? They did not ask themselves whether the numbers they were getting were at all reasonable or not. So we need to always remember to do these. If we follow these steps, I guarantee you at all times, okay, you will get a reasonable and a good enough answer. Okay, great. Do you, by the way, do you see my screen and my photo, or just the screen?
The screen and your photo.
all of them.
Okay. All right. So with that, we end chapter 1 and we move on to chapter 2. To recap, chapter 1 was all about units and measurements. We started by talking about what is physics about. We talked about units, about measurements, that nothing is very useful if it doesn't have a unit. Then we spoke about how measurements can be accurate and inaccurate. And we moved on to just generally speak about how do we solve problems in general. Prefix, no, just the ones you need to use. And again, ما في حفظ, okay? There is no such thing in sciences as حفظ. If you're trying to memorize in science, in math, in physics, in chemistry, you are doing something very, very wrong. You do not memorize at all in these. Actually, if you go to your Moodle, you will see under course information something called a formula sheet. And this is exactly the formula sheet that you will receive in your exams. There you go. This is the first page. Yes, some of them you get to know them over time. That, you know, kilo is 1,000, mega is 100,000, milli is 1/1000, micro is 1/100,000. But aside from these, you don't really need to memorize them per se. Okay. Also, you're literally given this in the exam. See, all your equations, every single one, pretty much, give or take, are given. Okay. All right. Moving on to chapter 2, which is vectors. If you're trying to follow Halliday-Resnick, this would be chapter 3 for you. But in our book, it's chapter 2. What are vectors? Why are they important? Are they a pain in the back? And how do I deal with them? Well, let's say you are trying to explain to me how to get from your home to my home. Okay. You can tell me المسافة بين بيتي وبيتك 100 كيلو. Okay, now I know the distance, but that is absolutely useless to me because أنا ممكن أروح 100 كيلو في أي من الاتجاهات. So that's pointless. It's useless. Yeah. If I actually need to get from my home to your home, okay, I need more information than simply the distance. At the very, very least, you need to find, I need to know 2 pieces of information. The distance, which you have already given me, 100 kilometers, but also in which direction. If I leave from Muscat and I go 100 kilometers north, I will end up in Batna. But if you live in Sharqiya, then those 100 kilometers are absolutely useless to me. I have actually gone further away from where I want to go than closer to it. And this, in essence, is the very definition of a vector. A vector is something that has a number and a direction. On the other hand, you have a scalar, which is something that has a number. That's it, nothing else. Okay, no, Faisal, not yet. Okay, so let's start by, how should we start this? Let's see. Okay, here's a question. With just numbers, I can add, I can subtract, I can multiply, I can divide, I can do multiple things. What about vectors? Can I do the exact same thing with it? Yes and no. Vectors can be added, they can be subtracted, they can be multiplied, but they cannot be divided. In mathematics, there is no definition of how a vector can be divided. The best we can do is multiply it by the inverse of another vector. Let's move on to a presentation, and hopefully things will become a bit clearer. Now, if you have actually gone through your book and read in advance, you will see that this is a very long chapter with a lot of stuff in it. Your book actually makes it look story, but it's actually quite simple. So share entire screen, this. Okay, now you should be seeing a presentation, right?
Yes.
Can anyone confirm to you?
Yes.
Okay, perfect, thank you. Okay, let's start by defining vectors again and what are their components. Vector is direction plus magnitude. Scalar is only direction. What are examples of vectors? Displacement, velocity, and acceleration. You will notice each one of them has an arrow next to it. We'll explain why there is an arrow in a second. Scalar is only a magnitude. Now there's something important that this doesn't say, so I'm going to write it down. Each one of them has a unit. So if I say 100 for scalars, it needs to be 100 meters. For vectors, it needs to be 100 meters north, for example. Okay. Now, what are examples of scalars? Time is just a scalar. It's just 2 hours, 3 hours. There's no direction for time. Temperature is just a scalar. 300 degrees, 200 degrees, 50 degrees. Mass, again, just a scalar. 50 kilos, 20 kilos, 1 gram, 2 grams. Vectors, on the other hand, have also a direction, so we represent them as arrows. So 6 kilometers north, for example, or 4 kilometers south. And whenever we write down a vector, we do it in one of two ways. Either we write them in bold. So if we're writing them using a computer, we would usually use bold. Now, when we're writing it down with a pen and paper, bold is not really an option. Okay, so we usually underline them or overline them. So we either, so for velocity, for example, V, it would either be V like this or V with an arrow on top. Not this. This is wrong because V with just a dash without an arrow on top means average V. In statistics, that dash without an arrow means average. We also have something else that we call the magnitude of a vector. And we usually put it in absolute terms, and that is always a positive number. And that is just the number part of the vector. Okay? So if I have 6 kilometers north, then its magnitude is 6 kilometers. Now, if I'm starting here, 6 kilometers north would be +6. 4 kilometers south would be -4. But the magnitude of 6 is equal to 6. the magnitude of -4 is equal to +4. So the magnitude is always a positive number. When is a vector equal to another vector? Now, we know when two numbers are equal, it's easy. Number 1 is equal to number 2. So if I simply want to look at A equals B and scalars, they need to be the exact same number. If they are anything that is not the same, then we call it not equal. It's a little bit trickier. It's a slightly trickier concept for vectors. For that, your book actually has a really, really good representation. Okay. We said the definition of a vector is a direction and a number. So two vectors are equal if and only if both two vectors are equal if and only if one, the magnitude are equal, and two, direction of A equals to the direction of B. Number 1 and number 2 need to be both true for vector A to be considered equal to vector B. Okay, so this is actually a rather good thing. Now we have multiple options here, A to E. Now A is parallel to B. They're both in the same direction, but their magnitudes are not equal. You will see that A is longer than B. So A is not equal to B. We cannot say they are equal. In the second option, they are the same length, but they are in opposite directions, so not the same direction. Again, they are not equal. Here they have the exact same length, but opposite directions, or not the same direction. Again, not equal. This is equal because they have the same length and the same direction. So here, A is equal to B. Now here we have, in this option, we have the same magnitude, but different directions, different magnitudes, and different directions. Both of them are not equal. Okay, and this is very, very important because in numbers, 2 minus 2 equals 0 for scalars. For vectors, that might not necessarily be true, depending on the situation. It only works in this case and in this case. Okay. Any questions so far? Okay. What operations can we do on a vector? Okay. Operations. One, We can multiply by scalar. 2, we can divide by scalar, and this is very, very important. We are dividing by scalar, not by another vector. We can add vectors. We can subtract vectors. We can multiply vectors. We cannot divide vectors. Okay. What are properties of scalars that are also nice properties of vectors? Vectors are A, commutative, B, associative, 3, distributive by scalar. What does this mean? It means that A plus B in vectors is equal to B plus A, just like normal numbers. It also means that if I have A plus B plus C like this, it's the same as A plus B plus C. So far, so good. Now, distributive has an important addition to it, only when by a scalar. So if I do alpha, which is just a number, a scalar, multiplied by A plus B, it's the same as saying alpha A plus alpha B. Or say, for example, I have alpha plus beta A. It's the same as saying alpha A plus beta A. Okay? This is only with a scalar. It does not work with a vector. And we will see examples of this, I think, in the next lecture.
دكتور تقدر نحفظها نجين في الاختبار كذلك.
ها؟
هذا لا نحفظها هذا لا.
أنا already قلت 3 مرات ما في شيء اسمه حفظ في الفيزياء. You do not memorize. You need to learn how to use them. But no memorization. Memorization will not get you anywhere.
Doctor.
Yes?
The difference between scalar and vector. Just for vector have direction?
Yes.
Okay.
Vector has a direction. So scalar is only a number. Vector is a number with a direction.
For example, this is magnitude and direction.
Exactly.
Okay, thank you.
Yeah, that's literally the mathematical definition of a vector, magnitude and direction. Mawadda, I will try my best to send them before the lecture, but most times, as you can see, I am going through multiple files at the same time. So I usually compile them after the lecture. Okay. Sultan, after the lecture, the slides are already available on Moodle. Okay. So for the previous 2 lectures, the slides are on Moodle. The whiteboard is on Moodle. Lecture 1 had slides. It's on Moodle. Lecture 2 did not have slides. I just went on the whiteboard. So the whiteboard is on Moodle. Okay. Okay. Let's do some examples and see how it works out. Addition of vectors. Let's do some examples. We have two ways to add vectors, either using graphical methods or using analytical methods, or what we call components. And we're going to do both of them. Let's first do using graphical methods. Okay. Now, most students seem to say this is easy. For me personally, I never found it easy, but it's entirely up to you. Here's a person. The mountains are in the east, and the person is moving 8 kilometers east. That same person then moves 6 kilometers east again. So what is the total that person moved? Well, 8 plus 6 in the same direction equals 14 kilometers east. So far, so good. Very simple. What if this person goes 8 kilometers east, but then goes 6 kilometers west, back in the direction? What is the resultant vector? 8 plus minus 6 is equal to 2 kilometers east. So now we define what we call a displacement vector and what we call a resultant displacement. And this is our first difference between distance and displacement. Okay, they're both with D. Okay, we have distance and we have displacement, and these two are not equal. Distance is a scalar. Displacement is a vector, and I'll give you an example. Okay.
Speed and velocity.
Speed and velocity are another example. Yes, good. And the reason speed and velocity are not the same is because they depend on distance and displacement. So speed equals, we'll come to this later, is distance over time. Velocity is equal to displacement over time. What is the difference between these?
Direction.
So let's say I start from this point and I move 10 kilometers in this direction. And then I move 4 kilometers in this direction. My distance moved, if I ask what distance did I move, the answer is I moved 14 kilometers. On the other hand, if I ask what is my displacement,
just 6.
then it is only 10 plus minus 4, which is equal to 6 kilometers east. I need to have a number, I need to have a unit, I need to have a direction. I need to have 3 things. Okay. So if I do this in 1 hour, say I'm walking, for example, okay, and I do this in 1 hour, my speed would be 14 kilometers per hour, right? But if I ask for what is my velocity, it will be 6 kilometers per hour east. What's the difference? Well, my speed tells me I am moving 14 kilometers an hour, which is correct. ما كذبت. أنا تحركت 14 كيلو. نعم 10 كانت صوب و4 كانت صوب. That's a different issue. But if I'm really caring أنه طيب أنا رايح من هنا إلى صحار كم وقت راح اخذ عشان اوصل صحار. It makes a very big difference because اذا انا رايح صحار كل 10 كيلو اروح ارجع 4 اروح 10 ارجع 4 اروح 10 ارجع 4 then my velocity is really only 6 kilometers per hour not 14 kilometers per hour لانه انا المسافه اللي راح اقطعها الفعليه ما بين هنا وصحار is 6 kilometers every hours not 14. Yes, Baba, keep. Okay. Let's see if there are any questions before I move on. Okay. Let us move. Okay. Now here's an important thing. Arithmetic cannot be used with vectors. We already said that, but I'm going to explain it in a different way again. It cannot be used if two vectors are not along the same line. What do I mean? Well, here's Papai, and he's going east, and then he's going north. Measure the distance. What is the distance moved by Papai? Well, just this plus this. Perfect. But what is the displacement? The displacement is not, say for example, this is 10 and this is 5. So then the distance would be 10 plus 5, 15, right? But if I want to know the displacement, I cannot add 10 east plus 5 north. It makes, it's like me going back to and saying, I want to add 10 apples and 5 oranges all over again. Okay, so what do we do here? Well, here's 10, here's 5, and my resultant displacement, my actual displacement will be given by the Pythagorean theorem. So I will need to do 10 squared plus 5 squared and then square root the difference. So 10 squared plus 5 squared square rooted. So this is 100 plus 25 square rooted. What's square root 125? Anyone? $11.2. Okay. What about the direction? How do I figure out the direction now? I know it's 11 in that direction, but how do I really define or write down ذاك الاتجاه? Well, I can give it using an angle. I can measure the angle between these two, and it's 27 degrees. Otherwise, what I can do is 5, 10. This is the angle I want, theta. So this is opposite, this is adjacent. So I will do tan theta equals 5 over 10, which is equal to half. Theta is equal to tan inverse of half, which is equal to 27
26.
degrees.
1.
26 point something?
26.5.
26.56 degrees.
56.
But since this was in just one significant figure, this is again one significant figure. Sorry, 2, 1, I don't know, 2, 1. This is arithmetic, so approximately 27 degrees. Okay? Again, I have an issue. Remember, 27 degrees from where to where?
Doctor?
I have to define, look, from the positive x direction, because I could also have 27 degrees from here, right? 27 degrees from here is very different than 27 degrees from here.
See sine, this cosine.
This is sine, this is cosine, correct. But at the end of the day, when I'm reporting my answer, what I will say is 11.2 kilometers at 26.5 degrees from positive x axis. Yeah? Or I can say whatever this is, 90 minus 27. 90 minus 27, 63. Or I can say 63 degrees from positive y axis. Either one is absolutely fine. So far, so good?
Yes.
Yes.
Okay. Any questions in typing? Good. Okay, back we go. Okay, now we already said that vectors are commutative and associative. We're going to give an example. What happens when we add the vectors in the opposite order? It gives us the exact same result. If I go d1 plus d2, I get dr. And if I get d2 plus d1, I will still get dr. It's the exact same result. So this is the graphical method that I told you some people find it easier. I personally don't. We call the tail to tip method of adding vectors. So we have d1, which is east. We have d2, which is at that angle. And the result will be somewhere in that direction. We know that. Either way, whether we do d1 plus d2 or d2 plus d1. Now, personally, I prefer to deal with numbers. But if you like photos, then this is an easier way. Let's see if we have understood. This is what we call a PI question, a mid of the class question. We have three vectors, A, B, and C, which are shown. Which of the four vectors at the bottom is the sum of these three? If I do A plus B plus C. I'll give you a minute, just try to figure it out. Take a look, bear in mind how many squares. This is 2 squares. This is 3 squares. And this is, well, 1.5 squares, give or take.
C.
A.
C.
Okay, some people are saying C, some people are saying A.
دي دكتور.
D.
C.
Okay, going all over the place. This is good. Thinking is good. Okay, let's see. I'm going to do first A plus C. A is in this direction, C in this direction, and C is more than A. So C is the direction of C is going to win. Okay, I will get something. If this is my axis, I will get something like this, right? For A plus C, A is going down, C is going to the left with a magnitude that is more than A. Now I will want to add B. B is smaller than them, and it is in this direction. So overall, what we will have as a result would be something like this. So the correct answer is
C.
C. Okay, if you want to do it mathematically, not graphically, this is minus 2 blocks down. This is minus 3 blocks left. This is plus 2 blocks right, plus 1 block up, right? So if I add them all up, what do I get? I get minus 2 down plus 1 up. So I get minus 2 down plus 1 up. This is equal to minus 1 down. And I have plus 2 right, minus 3 left, which is equal to minus 1 left. So I end up with this and this, which means my resultant will be in this direction, which is what we said graphically.
Doctor, can you explain it again? I don't
Which
get
one,
it.
the graphical method or the number method?
Graphic.
The graphical method is literally by looking. Okay, so the graphical method, which is reasons why I don't like it, is that it's simply by looking. I have never managed to do it in any other way than just looking at it in the graphical method. Some people manage to do it. Personally, I have never managed to do that. So we have a small line like this, a big line like this, and this. And then if I try to put them all one after the other, I will end up with this. If I try to draw them all one after the other, and the resultant is in this direction, because this is down and this is to the left. But personally, I find that very confusing to me. I don't get it. Okay. Let's move on to the subtraction of vectors. Your book really likes to draw a lot of stuff.
Doctor, I have a question.
Mm-hmm.
The fourth line in the graph, it's mean the direction of the angle, the direction of the closing triangle, or what? The meaning of the that line that we chose.
Say that again.
Up in the graph,
Okay.
if we get the answer is C. So that direction of that angle is meaning what?
This angle, you mean?
Yeah. No. The line is meaning what?
It is some number in this direction. That's it.
Okay.
Okay. Say for example, I am. Let's give these lines some number, some meaning. Okay. So I leave home. And I go down minus X kilometers. Then I decide to go upright, Y kilometers. Then I decide to go back towards home for Z kilometers. What is the result? The result is, if I started here from home Okay, I ended up somewhere here from home in this direction. Yeah?
I don't know, but I will see if I will understand that.
Okay. See, this is one of the reasons why I don't like the graphical method per se, because it is quite confusing personally to me. Did you understand it when we use numbers?
دكتور استخدم قاعدة المثلث تساعد كثير لأن هذاك ال A وال C يعطيك محصلة تقريبا قدر 13 وهناك 2 عندك فتنقصهم من بعض لأنه different بيجي different direction.
إذا استخدمت الأرقام صحيح، لكن السؤال أصلا كان بدون أرقام.
عندك يونت لأن ال A 2 يونت C 3 يونت ال B 2 يونت.
أيوه.
فتستطيع تستخدم من كذاك فالدايركشن عندك بيعطيك المتعاكس محصلة ال A وال C متعاكسة مع ال B فتنقسم من بعض بيعطيك الدايركشن صحيح ال A وال C.
Yes, but that is because we're using the units, so it's not purely graphical. But you're absolutely correct. Okay, so I draw it like this, and I have this 2 units down, and I will take this and this to start with. I have 3 units in that direction. Then what I get is this. 3 squared plus 2 squared, square root of 13. So this is square root of 13. Okay. Then I add this is an extra. Either way, we end up with a line in this way.
لكن الاتجاه بيكون دكتور الاتجاه بيكون زاوية فيكون تقريبا من نصف يمشي ما يمشي بالعرض الاتجاه الخط.
This is just for the number. It will come something like this.
Yes.
Not exactly in between. It will come at some angle.
واحد رايح فوق هذاك ال A.
Yeah. Let's move on and do it in terms of components, and then we'll come back to this later on. You will see that using components, which is what I personally prefer, is actually much, much easier. Okay, let's do subtraction. The negative of a vector is simply the same vector in the opposite direction. That is quite obvious. So step 1, we define the negative of a vector to be the same vector in the opposite direction. Let's try an example. What is V2 minus V1? So now instead of adding it, we want to subtract it. Well, step 1, V2 minus V1 is the same as V2 plus minus V1. This is simple arithmetic. So this is V2, this is minus V1, and my result will be in that direction. Forget numbers for the time being, we're just looking at directions. The idea that to take the minus of a vector, you just flip it. Skip this. So here's another example. We have 3 vectors, A, B, and C, and they're all shown in the same figure. We want to draw A plus B and B minus C. What would A plus B be? In what direction, give or take? A plus B will give me something in that direction. Like this. Okay, somewhere in between, because A is in this direction, B is in this direction, it's going to be somewhere in between. What about B minus C? Now, remember, this is C. So what would minus C be? It would be the same vector, but in the opposite direction, correct? So B minus C would become this. And now I add B plus minus C, which is again in this direction. Okay, so we simply flip the vectors. We take the negative of a vector when we want to subtract, and then we use addition. What if we want to multiply the vector by a scalar? Well, this is V. What is 2V? Does the direction change? Remember, a scalar is a number plus a direction. So if I multiply this with 2, I can multiply the number by 2, but I cannot really multiply the direction by 2, right? So it will be the same direction, just double the length. What if I do minus 4V? I flip it to the other direction, and then I multiply that number by 4. So I get a line that is 4 times as long, but in the opposite direction. Here's the part that I was actually looking forward to. Components of vectors. Let's see how much time do we have left. We have about 6 minutes left. I can start. I'll probably not finish, but I can start. Okay, I see many of you are confused. It will become clearer once we do components, I promise. Okay, first of all, what is the process of finding the components of the vector called? We call it resolving the vector into its components. And this is underlined because I will be using the sentence over and over and over and over again 1,000,000 times. Okay, during this course. Not only in this chapter, and pretty much every single chapter from now on, we will be using the term resolve into components. Resolve into components.
Doctor?
Yes?
It is better to start the component to the next lecture, because today it's more that confused. All of a sudden they are confused, so it's better to start it in the component to let them understand.
They'll be even more confused if we don't start it now. Okay, we actually already introduced the concept of components, but indirectly. I did not actually call them components. I simply put in some numbers. So hopefully this will give you some clarity before ending this lecture. So say, for example, we have a vector, or in this case, Superman, going at some angle. I did something without explaining it multiple times. I wrote the number for X alone and the number for Y alone, and then I simply added it up. Remember in this, what I did here, I gave these numbers, right? -2. And here for this one, I did something weird. I said it's +2 and +1, but I never explained to you why am I writing it in this way. Well, this is what we call resolving into components. Too many. Okay, if I have this vector D, then I can write it as a sum of 2 vectors. What is this vector in the Y direction? And what is this vector in the X direction? If I do that, I call it resolving it into components. And to do that, I need to do some maths. I'm not going to go into the details of how we do the maths in this lecture, okay, because it's going to confuse you. But what the important part is, when we have a really complicated vector, so I have something like this going at an angle, I can make the math easy by looking how much is this alone and how much is this alone. So when I need to add 2 vectors, one going like this and another one going like this, And instead of drawing it in a triangle and then trying to complete the triangle, see how many units here and see how many units here, and use Pythagoras and use a whole bunch of things to try and figure out what is the resultant direction and the resultant number, what I can easily do is take this vector, say it is x, well, it is these many units in the x direction, this many units in the y direction. Then I take this other vector of mine, I say it is this many units in the x direction and this many units in the y direction. And what I do is I say the resultant vector is the sum of these two numbers in x and the sum of these two numbers in y. So no drawing needed, no figuring out needed. ما يحتاج راس وذيل وذيل وراس. We simply stop this. ما يحتاج ذيل وراس وراس وذيل which direction and how do I figure it out and units and let me use Pythagoras theorem to figure it out and then do this bit and then that bit. It becomes very, very simple. We simply take the components of every single vector we're trying to add or to subtract and then put them, add all the components of one direction and all the components of the other direction and have a ready-made result for us. Okay, we're going to stop here today. If you are following through us with the book, you will see that we started section 2.2, coordinate systems and components of a vector, but we did not actually manage to finish it. So we will do that in the next lecture. But you will also notice that we have already started doing some parts of 2.3. So we have actually skipped ahead and then came back. Okay? Any questions?
Yes, doctor.
Yes?
Should we use the significant figures in this function?
Which function?
Like اللي هو مثل مال الزاوية لما نسوي ساين ثيتا تطلع مثلا 28 درجة فاصل حاجة.
أيوة. في آخر ستيب فقط لما نجي لما نجي نكتب آخر نتيجة فقط نجي نستخدم السيجنيفيكانت فيجرز. تمام؟ لما نجي آخر فقط ولما جالسين نسوي كذاك المسائل على السريع ما نعبر السيجنيفيكانت فيجرز. لكن لما نجي نحل مسألة بشكل صحيح فقط نستخدم السيجنيفيكانت فيجر اللي هو إذا آخر شيء. وعد إذا أول مسألة بدينا جمع A plus B بعدين C النتيجة بتظل نفسها. أيوة بتظل نفسها. أنا مجرد استخدمت A plus C أول لأنها أسهل. إذا تتذكرين إحنا قلنا أنه vectors are commutative معناته A plus B plus C is the same as C plus A plus B, B plus C plus A. It's the same thing. أحمد لا أي كويز.
دكتور هو قصده إن أنت قلت قبل كل محاضرة راح يكون في اختبار يفتح الساعة أو إنه يعني homework كأنه كتحضيري للlecture.
ما فتحناه اليوم ما سويت اليوم لكن بكرة إن شاء الله راح يكون حال محاضرة بعد بكرة.
دكتور قصد ال BI question.
أيوة. وش فيها ال BI question؟
يعني كنا إنه ما خضينا فعبالي يعني ما شيء ذا الفصل.
ما فهمت.
يعني عبالي ذا الفصل ال BI question من الغايات. فعشان كذا يعني شفت يعني ما خضينا للمحاضرة اللي قبل ولا تو.
ال PI question ما عليها علامات. هي طريقة علشان نوقف وسط المحاضرة ونسأل أنفسنا هل نحن فهمنا أو لا. نفس الشيء الريدنج تشيك ما عليها علامات، هي مجرد طريقة علشان نفهم بعض، عشان نوقف ونسأل بعضنا البعض أو نسأل أنفسنا هل بعد كل هالهذرة اللي هذرتها هل هي مفيدة ولا ما مفيدة؟ هل بالفعل فهمنا ولا ما فهمنا؟ طيب مثلها مثل الأمثلة اللي نعطيها، لكن أحد النقاط السلبية في كثرة الأمثلة هو أنه ما زال في كل الأمثلة أنا اللي جالس أتكلم. فالبي آي هو عبارة عن مثال، لكن المثال هذا بدال ما أنا أحله أنتوا تحاولوا تحلوه أول وحدكم وبعدين أنا أجي أحله علشان نشوف هل فهمنا ولا ما فهمنا. بس ما في علامات. من ناحية العلامات من ناحية العلامات في هذا الفصل في 10% توتوريال كويزز راح اشرح لكم. ما كان عندنا توتوريال حتى الان، اول توتوريال راح يكون الاسبوع القادم، فراح اشرح لكم قبلها كيف راح يكون السيستم. وفي 10% على اللابات والبقيه فقط متر وفاين. طيب على اساس ما تتشتتوا، ما يكون انه هذا الشيء عليه علامه هذا الشيء عليه علامه. الفكره هي انه خلينا وقت الكلاس كل اهتمامنا او في اشياء غير اوقات الامتحانات، هل نحن we try to enjoy the physics rather than just focus on the marks. Just happened here. ثواني. أسئلة ال PIQ هل هي موجودة؟ موجود مثلها في الكتاب اللي هو يسمونه أعتقد كاتبين شيء كأنه test yourself أو reading check شيء كذا. check your understanding. طيب check your understanding. وإذا تريدوا ممكن أحاول أنزلها في المودل الأسئلة. طبعا ما عندي الأجوبة لأنه الأجوبة بالعادة نتناقش فيها، بس أحاول أنزلها في المودل إذا لحقت.
دكتور.
أيوة.
بخصوص اللاب امس انا مسلمنا متاخر تقريبا وايد، يعني ساعتين او شيء. عادي؟
اللاب امس كان مفتوح التسليم لين الساعه 9، واول مره نحن قلنا ما نحاسب. بس اهم شيء لكل الموجودين هنا لازم ضروري تسلموه عن طريق المودل.
لكن
عن طريق
دكتور
الايميل ما ينفع.
الوقت حاول تزيدنا، يعني بما انه اونلاين مدده شوي.
الوقت راح ينقص مع مرور الوقت ما راح يزيد. لانه it's supposed to be a live session. بالعاده اذا انتم موجودين هنا يعني في SQ يكون اللاب مدته ساعتين فقط، ساعتين ونص بالكثير.
صح. لكن بما انه اونلاين حاول تزيدنا شوي وقت.
ترى الماتيريال هو نفس الماتيريال.
ايوه صح.
بس دكتور في فرق بين في الجامعة يكون ورقي فسهل، أما لما يكون أونلاين يكون في الكمبيوتر يكون صعب نتعامل سريع مع الإكسل وهذه الأشياء.
صح.
إذا اطبعوه، إذا تريدوا تستخدموا ورقي اطبعوه، ترى ما في إشكالية.
يعني عادي
ما لازم يكون إكسل ترى، وهذا ما مشكلة. تريدوا تسووا ورقي تقدروا تطبعوه عادي جدا. أنا راح أكلم اللاب انستراكتورز انزين بخصوص تمديد الوقت إذا فيه. بس يعني نحن اللاب عندنا يبدأ كل يوم الساعة 2، فإذا نحن البارحة سويناه من الساعة 2 لساعة 9. أمس كان في شوية شرح طويل ما significant، فنقول من 3 ل 9 يعني 6 ساعات.
صح.
بس أستاذ حقيقة
دكتور أنا رسلت لك إيميل عشان
ما كنا منظمين يعني بالمعلومات اللي نسويهم في الأسايمنت الموجود على اللاب.
ما هو لذلك أول مرة نحن قلنا ما راح نحاسب على الوقت.
بس راح نحاسب بالدرجات.
كيف؟
يعني دكتور في أسئلة نحن ما نعرف على أي، يعني على أي مثلا على أي جدول أو على أي مخطط.
المانيوال جدا واضح برقم الجدول برقم التيبل، كيف تسوي كل شيء أول بأول. وأنا قلت لكم من البداية أنه هذا الكورس الحين أنتم وصلتوا إلى مرحلة جامعية، عديتوا المرحلة المدرسية، فلازم انكم انتم يكون لكم ايضا جزء من المجهود في قراءة المانيوال. راح تحصلوا كل المعلومات جاهزة. فيعني انا كثير من الطلاب جاءوا امس يرسلوا لي ايميل بعد بعد اللاب يقولوا لي طيب نحن ما نعرف من اي نحن ما نعرف من اي هذا من اي تيبل نعمل الجراف. طبعا انا ما منتبه حتى ننجل كل الحين في طبعا 140 طالب وما تطلع لي كل الاسماء، فانا ما جالس اقصد حد معين. طيب لكن يعني هذا الشيء انا لاحظته بشكل عام. طيب هذا شيء انا لاحظته بشكل عام. فاطمه ما اختبار، اتس لاب، اتس لايف لاب، نعم عليه 10%.
دكتور طيب أنا
سارة نعم
دكتور
عادي بدون الأكسل. مروان نعم عادي نكتبه ونصوره. العنود أول مرة راح نحاول نمشي الموضوع، بس ترى نحن عندنا فوق 350 طالب، يعني إذا استلمنا 350 إيميل شيء مستحيل جدا نعمله. بدر نعم عادي الليكتشر خلص، هذا مجرد الحين سؤال وجواب. تيمة نعم اللي هو اللي كنتوا تعبوه. سلطان نعم الانسر شيت.
دكتور شيء محاضرة
أيوة.
ثانية اللي نقدر ندخلها مشان الشرح.
ايش؟
محاضرة ثانية مشان اللاب، لأن اللاب الماضي والله ما فهمت ولا حاجة. يعني في محاضرة ثانية لاب نقدر ندخلها عشان نسمع الشرح.
لا ما في، هو هذا الوحيد.
طيب دكتور ممكن تعيد لنا الشرح شوية بسيط ولا شيء؟
كانت فوق الساعة، ما ممكن إعادة، بس المانيوال في كل شيء. أنا أشوف إذا في عندي تسجيل ممكن أرفع التسجيل. طيب لكن بالعادة اللابات ترى ما في تسجيل. فاطمة نعم كان بس سكشن 21. بالنسبة للباقيين النقطة اللي كنت أريد أنا أقولها، أريد أوريكم شيء. يعني أنا أمس استلمت تقريبا 36 إيميل أسئلة أنه which table do we plot. طيب which table do we plot. أنا خليني أعمل شيء هنا. هذا هو المانيوال، نفس المانيوال اللي عندكم، نفسه هذا اللي أنا جالس الحين حاطنه على السكرين. ننزل tabulating data. how do you tabulate data كذا كذا كذا. graph plotting. how do you plot graph. بعد انزل. procedure. lab session 1 procedure. calculate average velocity and record your answer in the table. This average velocity is equal to the instantaneous velocity. Plot the graph of these velocities versus time. velocities versus time. نجي على هذا الشيت. طيب time position يعني ما هذا. time velocity في تيبل ثاني؟ ما في تيبل ثاني غيره. خلص اللاب هو هذا. يعني time velocity. يعني اذا حد يجيني يقول لي كان في واجد اشياء ونحن ما عرفنا مثلا ايش اي تيبل، انتم ما خبرتونا اي تيبل، لا موجود. plot graph of velocities versus time. اما انه اسلوب المدرسه اللي هو نفتح هذا الشيت ونقول لكم ترى ما هذا التيبل هذا التيبل، هذا ما ينفع في الجامعه. انتم كبرتوا الحين، لازم تعتمدوا على انفسكم. نفس الشيء هنا الكالكوليتنج افريج فيلوسيتي. طلاب يقولون طيب هذا التايم كيف نسويه هنا؟ كيف نكتبه هنا؟ حرفيا مكتوب هنا mid point of time interval. طيب الفيلوسيتي كيف احسبها؟ حرفيا موجوده هنا مع مثال. يعني كل شيء موجود في المانيوال من الف الى ياء. تمام؟ اوكي 1:30 وانتم اكيد عندكم محاضرات ثانيه، فما اريد اخليكم اكثر من كذا.
دكتور
نشوفكم ان شاء الله في المره القادمه. ايوه في حد كان يتكلم؟ ساره؟
ايوه دكتور، يعني شوف نحن ليش باغين زيادة وقت؟ يعني تعرف انت لحد ما نطبع نفس الشيء الشبكة معنا ضعيفة. أمس واجد يعني الوقت عارفين إحنا ما نفتح اليوتيوب الفيديو كذا.
6 ساعات is more than enough. 6 ساعات is more than enough. انا راح اتكلم مع شو اسمه مع اللاب كوردينيتور، لكن ما اعتقد انه راح يصير في تغيير، لانه 6 ساعات is way more than enough.
إنزين.
تمام. يعني للاسف الشديد في اشياء نحن ما بيدنا ترى كانستراكتور، وانا هذه واحده من الاشياء اللي كنت اكلم الاداره فيها. انزين، وحرفيا الكلام اللي راح اقول لكم الحين اياه هو ما كلامي انا، هو كلام اللي انا مثل ما تقولي امرت انه اقوله. طيب وين مكتوب؟ صبر احاول اقرا ثواني، بقرا حرف بحرف. ما قادر الاقي الايميل حاليا، بما معناه
ما تقصر.
it is the responsibility of the student to have a good internet connection and relevant resources and materials and a computer to do the work. Excuses of weak connections and or inadequate resources will not be accepted and exceptions can only be handled by the assistant dean level. هذا ما كلامي أنا، هذا الكلام لأنه لما جيت أقول لهم أنه طيب في طلاب كذا، في طلاب كذا، في طلاب مثلا الشبكة عنهم كذا، في مثلا يعني أنا حرفيا عندي كانوا عندي أحيانا طلاب موجود في مثلا ساكن في الجبل الأخضر، زين أحيانا مثلا تصير عندهم إشكالية هناك في الجبل ترى الإرسال. قالوا لي هذا هو. فإتس really not in my hand. أنا من ناحيتي أحاول أنه أحط الريكوردينجز، أحط هذا قدر المستطاع، في أشياء خارج عن قدرتي.
دكتور لو